In this video, I'm going to show you how to find the nearest point on a mesh surface in JavaScript and Unreal Engine 5.0. And to do that efficiently, we're going to create a BVH, or bounding volume hierarchy object, which will make those queries much more efficient than, for example, testing every triangle. So we're going to use that to build a little blueprint. I'll just show you what it's going to be like at the end. So here I dragged one in. It doesn't do anything by itself, but if we set a source static mesh asset, then it's going to basically initialize itself with that mesh, and then you see that there's boxes being scattered on the mesh surface, sort of randomly scattered. So this is what we're going to build. So let's get started. I've filled in a lot of the blueprint, and I'll just show you the critical parts that let us do that nearest point query. So I've got my rebuild generated mesh event. The first thing I'm going to do, this is something I find really helpful to do, is to save this target mesh in a variable. So you can just drag off that pin and go promote to variable. I'm not going to do it because I've already done it. But then later on, I can, instead of having to wire this node all over the place, I can just drag in that target mesh variable. So that's just a helpful tip. Okay, I'm going to make a random seed for the random scattering. I'm going to get that static mesh. I'm going to do a validated get. So in case you forgot how to do that, you can drag in the source static mesh get, and then right click and convert to validated get. And now it's only going to do the rest of this if that's valid. That'll help avoid errors. I'm going to copy from the static mesh into my target mesh. Okay, and so now here's where we're going to do something new. So I'm going to drag off that, and I'm going to go build BVH for mesh. So that's going to build a bounding volume hierarchy, assuming that mesh copy works. And then I'm going to put that in a variable. So you could drag off here and say promote to variable. I've already got one over here, so I'm going to do a set. It's very important to put the BVH into a variable. Don't wire it directly into other nodes, because if you do that multiple times, which we're going to want to do, multiple queries on it, it'll recompute it each time. Okay, then I'm going to wire the output mesh into, oh sorry, not that one, this target mesh, into a get bounding box. We're just going to have a little bit here. I made this function get box center and extent. That's because I need the box, the bounding box of the mesh. I'm going to use its center and half size to do this random point in bounding box node. So this is just to generate the random points. It could be generated lots of other ways, but this was a sort of convenient way. This is a custom function, get box center extent. I'll just briefly show it if you want to pause the video, where I just get the min and max and add them and divide by 2 is the center, and subtract max and min and divide by 2 is the half size. Okay, and then once we've got that set up, we're going to do a for loop for the number of points we want to scatter. And the loop body is going to be pretty simple. So we're going to right click here and type in nearest point, and we've got this function find nearest point on mesh. So that's what we're going to use basically in the loop body. So we need our target mesh. We'll drag that in. We need our BVH, and we need our query point. They always end up on top of each other. And then if it's found, the nearest result here, we can right click and split that, and you see it's got various fields, a bool of whether or not it's valid, the nearest triangle ID, the nearest position, and that's the point we want to place the box at. So we're going to drag that over here into the location we want to append a box. I've already built that node. And so if it nearest point is found, which it always will be, generally, unless there's some kind of error, we're going to append a box there. So let's compile that. Okay, that's this one here. Let's drag that in, set the mesh. You see it worked, except there's no boxes. So I did something wrong. Append box target. Oh, we need the target mesh for the box. There we go. Get, wire that in, compile. Okay, so one box appeared, but if you see we drag the points here, we're getting a bunch of errors. Now this is something that's important to understand about using these BVHs. The BVH is built for the target mesh back here, for the state it was in at that point, which was just the bunny. Once we've appended a box, the mesh is out of sync with the BVH. It doesn't automatically rebuild or anything like that. So there is a node to rebuild the BVH. We could do that each time we append a box. That's expensive, and it would mean the boxes would stack on top of each other, which is not what I want in this case. So what we need to do is these appends need to go into a different mesh. So I've got that already built down here. Oh, it wasn't actually the loop I wanted to break. So it's the same essentially the same stuff, but I'm just going to allocate a compute mesh first. And then I've got my for loop, random point, find nearest point, and append. That's all the same. And then when I'm done, I'm going to just, the append boxes here go into that accumulate mesh. And then at the end, I have to append that on the target mesh. So let's compile that and go have a look. And you see now that's all working. The cubes are there. If you remember the original one, the cubes were aligned to the surface. I'll just show you how to do that because that's a kind of useful thing. So remember, we're going to append onto this target mesh. So I'm going to get the target mesh down here, and I'm going to go get triangle normal, face normal. Okay, and I've got that triangle ID that was computed for the nearest point. So what I can do is wire that in here. That gives me a normal vector, which I'm going to go rotator, make rotator from Z. So then that'll orient the boxes. So then that's going to make a rotator I can plug in here. Compile that, and now the boxes are aligned to the surface, and I can drag them around. This is quite fast. You see, even with like 100 boxes, it's pretty speedy because of this BVH structure is basically what makes that fast. That makes it quickly to do all those nearest point tests. Okay, that's this example. Thanks for watching.